Okay, hi everybody. Today we're going to be going through 6.1 notes, angles of polygons. So let's get started. Our polygon interior angle sum. This is the sum of the interior angle measures of an n-sided n-gon polygon is n minus 2 times 180. Here, our n is our number of sides of the shape that we have. So our n here, again, is the number of sides of the shape that you will have. So if we apply this to example 1, find the sum of the interior angles of an irregular polygon. Here we have 1, 2, 3, 4, 5 sides. So we're just going to apply this formula with 5 sides here. So we have n minus 2, but here n is 5, so 5 minus 2 times 180. Now all we have to do is simplify this. If we simplify this, we get 3 times 180, and 3 times 180 will give us 540 degrees. Next, to find the measure of an interior angle of a regular polygon, use this formula, n minus 2 times 180 divided by n. Again, n here is our number of sides. Here with a regular polygon will always have all sides and angles be congruent. We have a regular polygon, all sides and angles are congruent. So in example 2, find the measure of each interior angle of a regular hexagon. So here we know we are dealing with interior angles and we are dealing with a regular hexagon. How many sides does a hexagon have? Well, we know that a hexagon has 6 sides. So we just have to apply this in the above formula. So that is 6 minus 2 times 180 divided by 6. Remember, n is our number of sides. Here we have 6 sides. If we simplify this, we will get 120 degrees. Next, we're just going to fill in these boxes with our different sides lengths of polygons. So our number of sides, if that is 3, we have a triangle. In a triangle, the number of triangles formed in a triangle is obviously 1, and the interior angle sum of a triangle is always 180 degrees. Next, a 4-sided polygon is called a quadrilateral. And we can form 2 triangles in a quadrilateral, and the interior angle sum is 360 degrees. Next, a 5-sided polygon is a pentagon. A pentagon we can form 3 triangles in, and the interior angle sum is 540 degrees. Next, a 6-sided polygon is called a hexagon. The hexagon we can form 4 triangles, and the interior angle sum is 720 degrees. A 7-sided polygon is called a heptagon. A heptagon can form 5 triangles, and the interior angles add to 900 degrees. An 8-sided polygon is called an octagon. An octagon we can form 6 triangles with, and the interior angles add to 1080 degrees. A 9-sided polygon we call a nonagon. A nonagon can form 7 triangles, and the interior sum of the angles is 1260. And finally, a 10-sided polygon is called a decagon. A decagon we can form 8 triangles, and the interior angle sum is 1440 there. And if you notice, if you get number of sides that are higher than 10, you can apply these to find the number of triangles formed or the interior angles, where n is the number of sides. Example 2, find the measure of each interior angle of parallelogram RSTU. First of all, we know that this parallelogram has 4 sides. We can see that visually. If we have 4 sides and we go back and look, 4 sides, we have a quadrilateral. And if we look back at our table here, quadrilateral, the interior angle sum is 360 degrees. So we know the interior angles have to add to 360 degrees. So now, if I notice, I have 3 different equations in here for each of my different angles. I know that all of these equations have to add together to equal 360 degrees. So I can do that. I'm going to take 11x plus 4, add it to another 11x plus 4, then add it to 5x, and add it to 5x. Those are all of my angle measurements, and I can set those equal to 360 degrees. Now I have an equation where I can solve for x, because when I solve for x, I can plug them back in to each of these angles, and I will know my angle measurements. So if I solve this, I have x's that I can combine. I have 11x, 11x, a 5x, and a 5x that I can combine. If I combine those, I get 32 x's, and then I just combine my 2 constants. That's a 4 plus a 4, and I get plus 8. This still equals 360 degrees. If I subtract 8 and subtract 8, I'm left with 32x equals 352. If I divide by 32 and divide by 32, 352 divided by 32 is 11. So here x equals 11. Now I need to plug that x back in each of these angles. So I know that angle S is 11 times x, but now I know x is 11, so I can plug that in, plus 4, and I just simplify that to get my angle measurement. So that will be 125 degrees for angle S. Since I know that angle U is the same exact formula 11x plus 4 as angle S, then I know that angle U will also be 125 degrees. Next, I have angle T. I know angle T is 5 times x, but now I know x is 11, so I can plug that in and simplify, so I get 55 degrees. And I also know that angle R is the same as angle T, so angle R will also be 55 degrees. Next, we have example 3. Find the value of x. So we don't have to solve for angle measurements here. We're just trying to solve for the value of x. Notice I have 4 sides here. 1, 2, 3, 4. I have 4 sides. When I have 4 sides, again, I have a quadrilateral. When I have a quadrilateral, my interior angles are always going to add to 360 degrees, just like example 2. So now all I have to do is take each of my angle measurements. I have a 10x, a 6x, a 6x, and a 3x minus 15. If I add all those together and set them equal to 360 degrees, I can solve for my value of x. So I'll have a 3x minus 15 plus 10x plus 6x plus 6x. And those are my 4 angles. And I set those all equal to 360 degrees because 360 degrees is the interior angle sum of a quadrilateral. So now I can solve for x. I have a 3x, a 10x, a 6x, and a 6x that I can combine. If I do that, I get 25 x's, and I still have that minus 15 as a constant. That is still equal to 360 degrees. If I add 15 and add 15, I'm left with 25x equals 375. If I divide by 25, divide by 25, 375 divided by 25 will give me 15. So x equals 15. That is my answer because that's all it was trying. That is what it was telling me to find, just the value of x. So we're done there. Next, example 4. A mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. When we have a regular pentagon, this means that all sides and angles are congruent. This is important. It says find the measure of one of the interior angles of the pentagon. So if we go back to our formulas that we listed here, this one right here, this is what we're talking about. to find the measure of each interior angle of a regular polygon, we are going to use this formula. Here on example 4, we have a regular pentagon, and we're trying to find one of the interior angles, so that formula will work perfectly for us. That formula is n minus 2 times 180 degrees divided by n, where n is the number of sides. So I know my number of sides here is 5, so I just have to plug that 5 in for n in my equation. So 5 minus 2 times 180 divided by 5. If I simplify this, I get 3 times 180 divided by 5. If I simplify that one more time, I'm going to get 108 degrees. So one of these angles here is 108 degrees. Next, we have our polygon exterior angle sum. This says the sum of exterior angle measures of a convex polygon is 360 degrees. Now, a convex polygon means that not all sides or angles are congruent. This is different than a regular polygon. A regular polygon, all sides and angles are congruent. If we have a convex polygon, then not all sides or angles are congruent. Next, to find the measure of each exterior angle of a regular polygon, use 360 divided by n, where n is the number of sides. If we move on to example 5, we need to find the angle measurements of these angles on this polygon. Notice that I have a bunch of equations. I have a 4x plus 5, I have a 6x, so on and so forth. Since this is a convex polygon, we can visually see that not all sides are congruent and not all angles are congruent. Since this is a convex polygon, we are going to use this value here. We know that the sum of the exterior angle measures of this convex polygon have to add to 360 degrees. So all we have to do here is add all of our angle measurements together and set it equal to 360. So I have a 4x plus 5 plus a 6x plus a 5x plus 4 plus a 5x plus 2 plus a 2x plus 3 plus a 3x minus 4. And all of those are equal to 360 degrees. Now I just need to simplify and solve for x. I can combine all my x's. I have a 4x, a 6x, 5x, 2x, and a 3x. If I combine those, I get 25 x's. And if I combine my constants, I get positive 10. And this still equals 360 degrees. Now I can easily solve for x. Subtract 10, subtract 10. I'm left with 25x equals 350. If I divide by 25, divide by 25, x equals 14. So if x equals 14, I can easily plug this x value in for any of these angle measures to find what that actual value of those angle measures are. I'm not going to do that just for the sake of time, but we can all plug x equals 14 into those equations to solve for those angle measures. Finally, example 6, find the value of x in the diagram. Again, here we have a convex polygon. Convex polygons, again, the exterior angles add up to 360 degrees. So I'm going to use that. I'm going to set it up the same way I set up example 5 here. So I'm going to add up all my angle measurements together, 5x and then a 4x minus 6 plus a 5x minus 5 plus a 4x plus 3 plus a 6x minus 12 plus a 2x plus 3 and finally plus 5x plus 5, and all this equals 360 degrees. Again, I'm going to combine my like terms, combine my x's. Here, I'll highlight them. We're going to combine all these x's. If I combine all my x's, I get 31 of them, so 31 x's, and then I need to combine my constants. If I combine my constants, I get negative 12. This still equals 360 degrees. Add 12, add 12. I'm left with 31x equals 372. If I divide by 31 and divide by 31, you can use your calculator here. 372 divided by 31, this gives me a value of 12. So x equals 12. And we are done. Thank you, everybody.